For centuries, Jupiter was the undisputed king of moons. It's the giant of our solar system, a world so vast you could cram about 1300 Earths inside it. So it makes sense that it would hold the record for the largest entourage of orbiting worlds. But here's a little secret. The title of this video is, as of right now, technically wrong, and that's what makes this story so exciting. In the last few years, astronomers have been locked in a quiet cosmic race. They have been peering into the darkness around the gas giants, discovering dozens of new tiny worlds. This hunt recently pushed Jupiter's official count to an impressive 97 moons. But while our eyes were on Jupiter, something incredible happened over at Saturn. In early 2025, a flood of new discoveries brought Saturn's total to a staggering 274 moons, snatching the crown from Jupiter. This is not just a story about planetary rivalry, though it's a story about how little we still know about our own cosmic backyard. It's the story of the chaotic, ever-expanding family of worlds orbiting the one-time king of our solar system, and why simply counting them is one of the greatest challenges in the modern science. Our story kicks off over 400 years ago with one man and a brand new invention. In 1610, when Galileo pointed his primitive telescope at Jupiter, he saw something that would shatter our view of the universe. He spotted 4 tiny points of light dancing around the planet, changing their positions night after night. These were not stars, they were worlds in their own right, orbiting another planet. It was the first definitive proof that not everything in the heavens revolved around the Earth. Today, we know these 4 as the Galileo moons, and they are some of the most fascinating destinations in the entire solar system. They are not just specks of rock, they are complex, planet-sized worlds, each with its own dramatic story. First, there's Io. From a distance, it looks a bit like moldy pizza, but get closer, and you'll find the most volcanic and active body in our solar system. Io is trapped in a gravitational tug-of-war between Jupiter's immense pull and the rhythmic nudges of its neighboring moons. This constant squeezing and stretches, called tidal heating, kneads Io's interior like dough, generating enormous heat that erupts through hundreds of volcanoes, spewing sulfurous plumes high into space. Next is Europa, the one that truly captures our imagination. Europa is an ocean world. Beneath a shell of shimmering cracked ice, scientists believe there lies a vast global ocean of liquid salt water. It's estimated this hidden ocean could contain more than twice the amount of water found in all of Earth's ocean combined, warmed by the same tidal forces that tortured Io. This makes Europa one of the most promising places to search for extraterrestrial life. Then we meet the giant Ganymede. Ganymede is not just Jupiter's largest moon, it's the largest moon in our entire solar system, even bigger than the planet Mercury. It's a world of rock and ice, so large that it generates its own magnetic field, the only moon we know of that has one. Its surface tells a tale of 2 halves, one dark and ancient, battered by billions of years of impacts, and the other brighter and younger, marked with the mysterious grooves that hint at a dramatic geological past. And finally, that's Callisto, the quiet one of the family. Its surface is the most heavily cratered landscape in the solar system, a frozen diary of the violent history of our early cosmos. It seems to have been geologically quiet for billions of years, making it a pristine relic from the dawn of our solar system. For hundreds of years, these 4 were the only moons of Jupiter we knew. They were the established royal code, but they were just the beginning. Before the stately, predictable orbits of the Galilean moons, the Jovian system descends into beautiful chaos. Here, dozens of smaller, stranger moons dance to a completely different rhythm. These are not perfect spheres, but lumpy, potato-shaped rocks, many just a few kilometers across. They are often found in groups or families, clusters of small moons sharing similar orbits, hinting at a common violent origin. Astronomers believe many of these moons were not born with Jupiter. They are cosmic immigrants, asteroids and comets that strayed too close to the gas giant and were snared by its colossal gravity. This is where we find one of the strangest phenomena in the solar system. Retrograde moons. These are the moons that orbit Jupiter backward against the direction of the planet's rotation. Imagine driving the wrong way down a multi-lane highway. That's the perilous life of a retrograde moon. These captured worlds tell the story of a younger, more chaotic solar system, a time when Jupiter's gravity acted like a giant cosmic vacuum cleaner, sweeping up the debris left over from planet formation. Finding and tracking these tiny, wayward moons is incredibly difficult. They are dark, they are small, and they are very, very far away. It's like trying to spot a piece of coal from miles away in the dead of night. Closer in, orbiting inside the path of the Galileans, are the inner moons, like Amalthea and Phoebe. These are the misshapen, reddish worlds constantly blasted by radiation and dust from Jupiter's powerful magnetic field. They orbit so close to the giant planet that they are inseparable from its faint, dusty rings, which they help create and maintain. This complex, chaotic system of regular moons, captured asteroids, and moon families is what makes the Great Moon Hunt so challenging and so rewarding. And it makes you wonder just how many more of these tiny worlds are still out there, waiting to be found. Let us know in the comments how many moons you think Jupiter will officially have by the year 2035. And if you're enjoying this journey through our solar system, make sure to subscribe for more stories of cosmic discovery. So, how do you actually find a new moon? You cannot just point a radiscope at Jupiter and expect to see one pop into view. The glare from the planet itself is so overwhelming that it blinds you to any faint objects nearby. Instead, astronomers have to be clever. They use powerful wide-field telescopes on Earth to take a series of deep images of the sky around Jupiter. Then, using sophisticated software, they painstakingly compare these images, looking for any faint dot of light that moves in a way that suggests it's gravitationally tied to the planet. It's a monumental task. You have to filter out background stars, distant galaxies, and the thousands of asteroids that also wander the solar system. Once a candidate is spotted, the real work begins. Astronomers have to track it for months, sometimes years, to precisely map its orbit and confirm that it is in fact a stable moon and not just a passing rock. Only after its orbit is securely determined can it be officially recognized by the International Astronomical Union, the governing body of astronomy. This is why the moon count can be in flux for so long. There are often dozens of candidate moons just waiting for that final confirmation. This is what makes the recent burst of discoveries so remarkable. Teams led by astronomers like Scott Shepard have been at forefront of this hunt, pushing our technology to uncover these hidden worlds, and the game is about to be completely transformed. Upcoming observatories like the Vera C. Rubin Observatory and the Nancy Grace Roman Space Telescope are expected to find hundreds, if not thousands, of new objects in the outer solar system. This will almost certainly lead to even more moons being discovered around both Jupiter and Saturn. The race is far from over. While astronomers on Earth hunt for new moons, a new generation of robotic explorers is heading out to visit the ones we already know. For decades, our best views of the Jovian system came from flyby missions like Voyager and Cassini and the Galileo orbiter, but we are about to get a much closer look. Two monumental missions are currently on their way. The first is the European Space Agency's JUICE mission, short for Jupiter Icy Moons Explorer. JUICE is on a long journey to the outer solar system where it will perform detailed flybys of Europa and Callisto before doing something truly unprecedented, entering into orbit around another planet's moon, Ganymede. It will map Ganymede's surface, study its unique magnetic field, and use ice-penetrating radar to search for pockets of liquid water within its icy shell. Following close behind is NASA's Europa Clipper mission. As its name suggests, its prime target is the ocean world Europa. It won't orbit Europa directly. That would expose it to the hardest parts of the Jupiter's deadly radiation belts. Instead, it will make dozens of close, fast flybys or clips swooping in to scan the surface with a powerful suite of instruments. It will measure the thickness of the ice shell, analyze material that has seeped onto the surface, and search for plumes of water vapor that might be erupting from the ocean below, revolutionizing our search for life beyond Earth. So, Jupiter may have lost its crown to Saturn, at least for now, but the story of its moon has never been more compelling. From the four planet-sized worlds that rewrote our place in the cosmos to the dozens of tiny captured wanderers in the dark, Jupiter's system is a miniature solar system in its own right. It's a laboratory for understanding how planets form, a museum of the solar system's violent past, and a frontier in our search for life. The exact number of moons is almost secondary to the real story. That our solar system is more dynamic, more chaotic, and more full of mystery than we ever imagined. The great moon hunt continues, and with every new discovery, the family of worlds orbiting the giant king grows, reminding us that there are still so many secrets waiting to be found in the dark.